Good morning.
Good morning.
Good morning.
All right, so everyone there in Holbrook?
Say that one more time.
Cyrus and Caitlin are missing.
Caitlin and who else?
Cyrus are absent.
Okay. And let's see. Is everyone there at Joseph City? Looks like everyone's there. Okay. All right. So this is me sending out love to the volleyball players. So this is my only volleyball shirt that I have. But I love it because on the back it says be strong. So that's kind of, a good logo for me, or a good motto, I guess I should say. All right, well, so today we're going to finish up 2.5 and do some damage on 2.6. We might even finish it too. It's a super short section. All right, then tomorrow, remember we have set up the chapter 1 test, and so we're going to do that, and then we'll do work on quizzes next week. Okay, so chapter 1 test tomorrow. Today we're going to work on 2.5. So does anyone have any questions, comments, concerns before we get started?
Oh yeah, I have a question. Just so did you say fall break? So next week, we still have this class.
Yeah.
Yes. Yes.
So Monday, Tuesday, and Thursday.
Yes.
And so if we can't come, we're supposed to send you an email with the reason why and everything.
Right. And if it's something that's out of your control, then we might deal with that differently than if it's where you just choose to not come to class. Okay. All right.
Are we supposed to come Wednesday?
Is it?
I'm not even sure.
Well, I've been thinking about that, and see, normally I would say yeah, but that seems a little. I'm wondering what to do as far as for you guys. Now, Joseph City, you guys have school next Wednesday, correct? Yeah. So what I might do, I might talk to Miss Smith about seeing about if we can do an alternate time for the quizzes next week for you guys, because I kind of don't want to make you come in an extra day. So we might negotiate that so that you don't have to come in on Wednesday of your fall break. Is that all right? Well, you'll still have to take the quizzes for next week at some point. I just might, maybe on like Tuesday after class, you guys could do it, or on this Friday or something. I was going to talk to Ms. Smith about that today, but she wasn't there. So I'm going to kind of negotiate with her and see what her availability is. But I guess kind of what I'm thinking is where it is your fall break, I kind of don't want to make you have to come to school just to take the quizzes. So I'll try to figure out something. Do you guys have any ideas? I'd love to hear them. Okay, well, I'll talk to Miss Smith, and then I'll get back to you guys. Get back to you on Thursday. We'll kind of make a decision then. Okay.
Mr. Strong?
Yes, please.
Can we take it on Friday instead, since we don't have no class?
This Friday?
Yeah.
So take next. Yeah, we could probably work that out.
Okay.
Okay. So then, okay. So what that would be? Let's see. Okay. Let's kind of map that out. So this Wednesday, Okay, this Wednesday's the test. So it would be quizzes on 2.2, 2.3, and 2.4. And we actually have finished those, so that might work out. Okay? So I'll talk to Miss Smith tomorrow and we'll confirm. And then that will be our plan. So I'll set up Holbrook to take the quizzes on Friday, and then for those 3 sections. And then Joseph City, you guys will just take it regular on Wednesday.
Mr. Strong, Holbrook also has half days Thursday and Friday.
It's parent teacher conference.
Oh, that's true. So probably at 11, you're what, in like 7th hour or something like that?
Yeah.
So that might not work. To take
Well,
it on Friday.
Maybe if you open it up for like 2 hours at a time, like from 10 to 12, then they could either miss their sixth hour class or 7th hour class.
Well, do you know what's gonna happen? They start with 5th, 6th, and 7th, and then I'm not sure what's going on that from 11 to 12. Do you guys know?
Probably.
I'm not sure.
Could
Yeah.
Naomi, between now and tomorrow, could you talk to Mr. Faturis and see if you can? Because
He just came in. He just came in.
he just came in.
Yeah.
Dang it, we missed him.
Someone go get him.
You want me to go get him?
Yeah, go
Yeah,
get him.
go get him.
Thank you.
All right. So in the meantime, let's go ahead and get started on. We're on 2.5 on the back side, okay? And then hopefully Mr. Vituris will come back and we can kind of work this out. Okay, so, let's see, wait just 1 second. Let me do one more thing here. All right. Okay, so the intersection of 2 sets denoted with the upside down U, the intersection symbol, is the set containing all elements that are in the set A and set B. Now, notice that how I write the and. Again, I did the or yesterday like this and the and like this, so you could remember which symbol goes with which. So with the and, you're looking at the overlap, the intersection of the 2. Okay, it's kind of like when you have 2 streets that go perpendicular, and the intersection of the 2 streets is the part in the middle that's in both streets. All right, so did you find him?
I couldn't, but I'll find him and I'll email you the times.
Yeah,
Later.
just let me know what I'm curious about, and it's all I know when I saw the schedule is that I don't have to go to Holbrook on Friday because I don't do afternoons there. Mm-hmm. But so I didn't even look at Friday's schedule, and so
Yeah.
so 5th, they're starting with 5th, 6th, 7th, and then I don't know. So yeah, so we'll check. That would be great, Naomi. Thank you. Okay. Excuse me. So if we have says graph the solution set that satisfies the following. Okay, so we have the green inequality and the blue. All right, so you graph each one separately first and then interpret the answer. So to do the green, you solve it for y by subtracting 2x and dividing by 3. So you get y is less than negative 2/3 x minus 1. Okay, so you find the line. So go to negative 1 on the y-intercept. The slope is negative 2/3, so you go down 2 and over 3. And then you make your line dotted because it's just less than and not or equal to. And then since it's less than, you're going to shade which way? Of above or below? Okay? So above, give me thumbs up. Below, thumbs down. All right, so thumbs down. So we're going to go below the green. Okay? All right, next. on the blue, x is less than 1. Okay, so you graph x equals 1. So that would be a vertical line through 1. And then it's dotted because it's just less than, not or equal to. All right, and then, all right, so less than, we're going to go to the left or to the right. Okay, so show me your hitchhiking abilities here. Okay, to the left or to the right. Okay, we're going to go to the left. Okay. Okay, so now we want, let's see, so this part right here would be. All right, so what we want when we have an and, that's the intersection. So we want the stuff that is in green and blue, okay? So not this stuff up here, because that was just shaded in blue, okay? Not the stuff down here that's shaded just in green. But from here on over, it's green and blue, so that's the intersection. Now, if I change this word and to an or, then we would say anything that's green or blue would be our answer, and so it would be all of this right here. Okay? All right, so go ahead and try practice 2B, please. Now, I kind of miss the days when the technology permitted me to let students come to the board. That's kind of what I really miss. But especially in these problems, because there's always some students that make these graphs so much prettier than how I make them. And I always like that, seeing, real pretty graphs. So using different colors or, whatever. But let's just take a look at what I've got here for the answer. Okay. So clearly I did this graph because it's pretty ugly. But the little wedge here in the middle is the answer, because that's the part that was shaded both in red and blue. So I made it purple. So this little wedge there in the middle, that is the answer. Okay. So any questions on that? Anyone like me to go over going through the graphs? Yes? Okay. All right. So this first one is the red one. So again, we solve it for y. So I subtract 5x from each side and then divide by -2. Now, when you divide by a negative, remember you've got to switch the inequality sign. So it's going to become greater than. So y is greater than 5/2 x minus 5. So I go down here to -5, and then the slope is 5/2, so I go up 5 and over 2, make it dotted, and shade above. So that's the red. Okay? So any questions on the red? All right, so the blue, it's already in slope-intercept form. If it helps, you can think of y equals x is y equals 1 over 1x plus 0. Because the y-intercept is 0, the slope is 1, so you go up 1 over 1. Since it's or equal to, you make it solid, and then you're going to shade below. And so then the answer is the stuff that's shaded both times because it's intersection. And so you what's shaded in both red and blue, that's the part that I made purple there so you could see the answer. Okay? All right, any other questions on that? Okay, unions and intersections of regions of the plane can also arise when solving inequalities involving absolute value. Now, to me, this is really where we test your graphing skills and your understanding of absolute values. Okay, so I rewrote the little rules for absolute value inequalities because remember, to solve them and to graph them, the first thing you want to do is write them as compound inequalities. So the absolute value of x is less than a is negative a is less than x is less than a. And so that's less than. And absolute value is greater than a becomes x is less than negative a or x is greater than a greater. So if you've forgotten these in dealing with absolute value inequalities, you might want to write those rules down on this paper too, because you're going to need that. So when you're graphing an absolute value inequality, the first thing you do is rewrite it as a compound inequality to get rid of the absolute value symbols. Okay? So it says graph the solution set. All right, so we have the absolute value of x plus 2 is greater than 1. Intersect the absolute value of y minus 1 is less than 2. All right, so before you start graphing, you need to rewrite these as compound inequalities. So if it's greater than, that becomes an or. So the compound inequality is x plus 2 is greater than 1. So the same thing without the absolute value symbols. Or x plus 2 is less than negative 1. So you change the inequality and the sign there. So simplifying there, we have x is greater than negative 1, or x is less than negative 3. Now, you can go ahead and graph those or just work with this. So I'm going to go ahead and simplify this, rewrite this absolute value inequality as a compound inequality. So with a less than, it becomes negative 2 is less than, the stuff inside is less than positive 2. And then to simplify, add 1 to each part. So we get negative 1 is less than y is less than 3. All right, so any questions so far? All right, so now the graphing. All right, so we have, let's do this one first because it's kind of the easiest and kind of the coolest. So y equals negative 1 would be this horizontal line. Y equals 3 would be this. So this is saying we want the y values between negative 1 and 3. So it's these parallel lines, and then we want to shade in between there. Okay? So it's this right here. Okay, now, the green is x is greater than -1. So here's -1, and we're shading to the right. Or x is less than -3. So over here. So we've got those two intersecting this right here. So the part that's shaded both in purple and green. So this part here and this part here is our answer. So not the very middle that's just purple or pink or whatever, and not the part that's just green. And since it's intersection, we want what's shaded both times. Okay? All right. So let's have you try practice 2C. I'll go back to the graph. All right. So let's take a look at what you've got here. So first, the greater than, absolute value of x minus 3 is greater than 1. You write as x minus 3 is greater than 1, or x minus 3 is less than -1. So you get x is greater than 4, or x is less than 2. So when you graph those, you get this in green here is greater than 4 or less than 2. Okay? So any questions on the first part? Okay, then, so y minus 2, an absolute value of y minus 2 is less than or equal to 3. Because it's a less than, you rewrite it as negative 3 is less than or equal to y minus 2 is less than or equal to 5. And then you add 2 to each side and you get negative 1 is less than or equal to x is less than or equal to 5. So that graph would be the stuff between y equals negative 1 and y equals 5. Whoops. Okay, so any questions on that graph? So now when you put them together, you're looking for the intersection. So when the intersection would be the stuff that's shaded twice, so that would be the stuff that I've got here in black. That was shaded both in green and purple. Okay, so that would be the answer. All right, any questions on that? All right, so how many of you got that right? Give me, all right, awesome. Okay, super. Because that's really the hardest of these graphs. Okay. All right, so now we want to talk about how to do this in the calculator. Okay. So to graph an inequality on the calculator, number one, you solve for y and plug into the y equals. Number two, determine if you shade above or below. Number three, you graph and then interpret the answer. Okay. All right, so let's go through an example, and I'll go through these steps. All right, so let's just do one inequality on the calculator here. So let's just so here you solve for y and plug it into the y equals. So it would be y would be greater than 2x plus 5. All right, so now to graph that, you go to the y equals, and then so you put in 2x plus 5. Okay. Oops. Oh, well, let's just start over. 2x plus 5. Okay. Now, to figure out how to shade it, what you do is if you arrow over to the left, okay, in the little box, on my screen and on the newer TI-84s that are color, you have color. But either way, if you press enter on that, then you can cycle through the different ways that it's shaded. On this, if I go to this line, then when it has the little triangle that is above the line, then that means it's going to shade above. If the triangle is below, then it'll shade below. So this one I want is greater than, so I'm going to shade above. So this is what I want. So I press OK, and then I press graph. And so then it's going to graph the line and then shade above. Okay? Now, let's see. I wanted to see. I don't think. I don't think you have an option. Okay, so you can make it dotted, but if you're going to shade, the calculator doesn't let you do solid or dotted and then shade above or below. You kind of have to interpret that. So you can't make the dotted line and then shade. Okay? All right, so go ahead and try practice 3 and see if you can put it in your calculator. Remember, you have to solve it for y first and then figure out how the shading is going to go. So, a couple of years ago, I taught pre-calculus class about this, how to shade on the calculator and everything like that. And then for the rest of the period, one of my students was just busy working on the calculator, and I thought, well, I guess he's figuring stuff out or whatever. So I didn't really say anything. And then afterward, he brings up his calculator, and he's got the calculator graphing the Batman logo. And so he spent the whole time trying to figure out different equations that he would use and how to shade it. And I mean, I thought that was pretty cool. So anyway, so let's look at this one. You can kind of compare your work. So first, when you put it in slope-intercept form, it's going to be y is greater than negative 4x plus 2. So then when you graph the line, you're going to shade above. So depending on which version of the calculator you have, it should look like one of these. Now, when you write it on your paper, though, like if you were to do it on your paper, you would want to make the line dotted because it's not really clear how that it's dotted here. But since it's just greater than, you would make your line dotted on your paper and then shade above. Okay? All right, so any questions on that? All right, so how many of you got that right? The shading part with the calculator. Okay, so any questions? Anybody need any help with that? Okay, well, that's it for 2.5. And so we are going to go on to 2.6. All right, so 2.6 is going to be an introduction to circles. Now, I know you've studied circles in geometry before, but we're going to do it a little bit differently. We're going to, the reason why this is in this section is because we're going to focus a lot on graphing circles and so on. Okay? But this is, just so you know, this is the last section in chapter 2. And so we're going to be ready for another test here pretty quick. So they're going to start coming a little faster now. That chapter 1 just seemed to last forever. But anyway, we'll be all right. So standard form of a circle, graphing circles. Okay. All right, so the standard form of a circle of radius r and center hk is x minus h squared plus y minus k squared is equal to r squared. And it might help to actually draw a circle. The center C, its the coordinates are hk, and then radius. The radius is the distance from the center to the circle itself. Okay, so let's say we have a center at -3, 7, and the radius is 4. And the question is, find the standard form of the circle. Well, this is just a plugging into the formula exercise. So it'd be x minus h, so x minus a -3 squared, plus y minus k, so y minus 7 squared, equals r4 squared. Okay, and then we just clean it up a little bit. X minus a -3, we write that as x plus 3 squared. And then 4 squared, we write that as 16. And that's it. All right, so go ahead and try practice 1A, please. All right, so Madison, when you've got it.
I got x plus 2 squared plus y minus 7 squared equals 9.
That is correct. Good job. Any questions on that? Okay. All right, so how can, that problem is so easy, how can they even get hard? Well, it's not hard, but they can get a little bit more difficult if instead of giving you the center, I maybe tell you the endpoints of the diameter or the whatever. So this is important for those type of problems. The midpoint of the diameter of the circle is the center. Okay? So in these type of problems, we're going to need to remember the midpoint formula. Okay? So the midpoint formula is you just average the x's and average the y's. That's how you get the midpoint of 2 points. So the other thing that we might need to know is that the radius is 1/2 the diameter. So if we calculate the diameter, then the radius is half of that. And the other formula we might want to remember is the distance formula, to find the distance between 2 points. Okay? So we had all of these back in, I think, 2.1. But so the distance between 2 points, you take the difference in the x's squared plus the difference in the y squared, and then take the square root of the whole thing. All right? So, let's say that we're just given the endpoints of the diameter and we want the equation of the circle. Well, now we don't know the center or the radius, so we have to calculate those. Okay, so first, to find the center point, we take the midpoint. So that we add up the x's and divide by 2, add up the y's and divide by 2, and so we get 3/2, 7. So the midpoint of the diameter is the center point. So when we're in our final answer, the h and the k, we're going to plug in 3/2 for h and 7 for k. But we're not quite there yet. Next, what we need to do is find the radius. Well, the radius, I could either take the distance between the center or midpoint and one of these, or take the distance between these two and then divide it by 2. I think, let's see which one I did. I think I'm going to want to use the original points because, let's see, did I use original points? No. So, okay, so the radius, okay, so if I take the distance between this one, the midpoint here and this one, so the center and this point, I could use either point. So 3/2 minus 0 squared plus 7 minus 4 squared, okay? So I'm going to, so 3/2 squared plus 3 squared. So 9/4 plus 9, that's 11 1/4 or 11.25. All right, so I have a center. I calculate with the midpoint formula is 3/2 comma 7. The radius squared is 11.25 or 11 1/4. Now, why didn't I solve for r? Well, because in the formula, the standard formula for the circle, you've got to have r squared anyway. So there's no sense in taking the square root and then squaring it back. Okay, so this in blue here is the final answer. So it's x minus the h squared plus y minus k squared equals r squared. So you get the center from the midpoint formula, the r squared from the distance formula. All right, so go ahead and try practice 1B. I'll leave this one up here. All right, so Avery, what's the center point?
-1, 2.
-1, 2 is correct. Okay? -1, 2. All right, Serena, what's the distance? Or what's the radius? Let's say it that way.
4.24.
4. Okay, so the square root of 18. So actually, you know what? I should have said what's r squared. Okay? Because you got to put r squared in the formula. So you're right, it's 4 point something. So, but there's no sense in taking the square root of it and then squaring it back. Okay? So r squared is 18. All right, so Serena, what's the final answer then?
The final answers.
So what's the standard form of the circle that has this center and this radius squared?
X plus 1 to the second power plus y subtract 2 squared equals radical 18.
No, it's r squared in the formula, so it's just 18. Okay. So in the original formula, it's equal to r squared, so it's just 18. Okay. All right. So good job. Good job, everyone. Any questions? Okay. All right, to write the equation of a circle from its graph, you must identify the center and the radius. Because that's what you need for the equation. Okay? So you look at this graph and then you write down the center and the radius. And then you can use the equation. Okay? So for this one, all right, so what's the center point here? Anyone?
2, 0.
2, 0. And what's the radius?
2.
2. So you write that down, and then you can say, okay, then this equation of the circle is x minus 2 squared plus y minus 0 squared equals 2 squared. Okay, then you clean it up a little bit. So y minus 0 is just y, so you get y squared, and then 2 squared would be 4. Okay? All right, so go ahead and try practice 1C, please. All right, Rebecca. What do you have? All right, so Rebecca, what's the center of this circle in practice 1C?
3, 0.
3, 0. And what's the radius?
3.
3. Okay, so if the center is 3, 0 and the radius is 3, then what's the equation?
In parentheses, x minus 3 squared plus y squared equals 9.
That's correct. Okay? Any questions on that? All right, now the last part that we're going to do today is about graphing the circle. So given the equation for a circle, we need to determine the center and the radius. Now, if it sounds like I'm repeating myself, I am repeating myself. Because you're always going to need the center and the radius. Okay? So here, if I want to graph this, then you find the center first. So it's the opposite of this number, -4, comma, this number here. Remember, in the formula, it's x minus h, y minus k. So the k would be -4, 2. And then the radius is the square root of this number. So the radius is the square root of 10, which is going to be a little bit more than 3. So to graph that, you graph the center point first, so -4, 2. And then you go up 3 and a little bit, down 3 and a little bit, left 3 and a little bit, right 3 and a little bit, and then connect those dots in a beautifully circular fashion. Okay? So go ahead and try practice 2A and see if you can make your circle as pretty as mine. But I have to tell you, I did cheat, as the computer helped me on that. I really can't draw that good. Whoop. Okay, so is it graph A or graph B? All right, I'm seeing a lot of B's in Joe's City. So 2, -3. So 2, -3. The radius is 2, up 2, down 2, left 2, right 2. So it's graph B. All right, well, we'll pick it up from there tomorrow. Or no, tomorrow you're taking your chapter 1 test. We'll pick it up from there on Thursday. Okay? Good luck. May the force be with you. Have a great day. Good luck on your volleyball game.